Initially, no charge, no energy stored in the capacitor because Vc of t equal to 0. That's what we assumed. Vc of t equal to Vc of t equal to 0. It means no energy in the capacitor initially. That's why already I told you that the capacitor acts like short circuit. At t equal to 0, it acts like short circuit. That's why the circuit becomes at t equal to 0 plus, the circuit becomes like this. 5 volt and 10 ohm. That's why 5 divided by 10.5. That's why the current starts at 0.5. Current starts at 0.5 ampere. But suppose the capacitor has some charge initially. Let us assume that it has 1 volt. In that case, let us assume that that voltage opposes the applied voltage, means V naught equal to 1 volt. It acts like a battery. The capacitor will act like battery. Polarity depends upon the initial charge. It may have like this. This is positive, this is negative, and with 1 volt, or it may have this is negative, this is positive with 1 volt. 1 volt or 2 volt or 0.5 volt. Some voltages may be in that. That is called initial condition. That is called what? Initial condition. Initial condition. That is called initial condition. The capacitor may have initially some voltage, means the initial condition of the capacitor is 1 volt. Maybe it may be top side may be positive or top side may be negative. Polarity may be different. So that is called initial condition. Similarly, inductor will store energy in terms of current, just opposite. They are complement to each other. Capacitor stores voltage, means in terms of voltage, means inductor will store energy in terms of current. It will store current in terms of current. Inductor stores current in terms of current. Energy will be stored in terms of current. That's why initial condition of the inductor is open circuit. Initial condition of the inductor is open circuit at t equal to 0 plus. At t equal to 0 plus. We are mathematically, this can be, the 0 can be defined two ways. One is 0 minus, 0 plus. Both are 0 only. Just after, in other words, this is called 0 plus. This end is called 0 minus. You can assume like that. You can assume like that. When t equal to 0 minus means bottom, 0 plus means top. Physically, it won't exist. Mathematically, it is possible, but physically, it is not possible, not at all possible. Some micro or millisecond will take to reach from 0 to 5 volt. 0 to 5 volt, but mathematically, we are assuming that it is like step. Mathematically, we are assuming that it is like step. But inductor, if no charge, no energy in the inductor, means no current initially, means it is an open circuit. Inductor is an open circuit. Suppose the inductor has some current initially, means it will be a current source. Capacitor is a voltage source. Capacitor with initial charge is called voltage source. Inductor, initially it has some current, means it is a current source. It is a current source. Suppose you are having a circuit like this. You are having a circuit like this. You are having a circuit like this. This is L. This is R. At t equal to 0, it is closed. 5 volt. R equal to 10 ohm. L equal to 5 henries. Initially, it acts as open circuit. That's why voltage across the inductor is initially 5 volt. because it is open circuit initially. No charge in the, no current in the inductor initially. That's why initially the voltage across the inductor will be VL, will be 5 volt. And then it starts decreasing. Finally, it comes to 0 volt. It means it becomes conductor. Already we have seen this. Inductor becomes conductor. After some time. If it is a DC current, initially it is reluctant to accept that current. Then finally it becomes 0 resistance. 0. No reluctance after that. Initially it reluct, then it allows. Therefore, the current, it becomes conductor. That's why the voltage across the inductor becomes 0. Initially is 5 volt. What happens to current? Initially current is 0 because open circuit. After that, current increases. What is the final current? The inductor becomes conductor. That's why only this resistance. That's why 5 divided by 10, 0.5. The maximum current is 0.5 ampere. Maximum current through this circuit is 0.5. At steady state, the current will be 0.5 ampere. And during transient, increases from 0 to 0.5 ampere. During transient, increases from 0 to 0.5 ampere. Now we are going to study about this transient circuit. This is very simple circuit. That's why we are qualitatively analyzing. We are not seeing quantitatively. We can find expression that is called quantitative analysis. Now we are doing qualitative analysis. What will happen? That we are, by imagination, we are analyzing. This is called qualitative analysis. So far we did qualitative analysis. We can do quantitative analysis. Before that, the initial condition of the capacitor is already I told you that it is a short circuit. It is a short circuit. VC equal to 0. When T equal to 0 plus. What is 0 plus? Just after turning on the switch. If initial charge is there, then it is acts like a voltage source. VC equal to some say V0 volts. V0 voltage. This is VC equal to at T equal to 0 plus. What is the difference between the two? This is the capacitor has initial charge, here no charge. Similarly, if you consider the inductor, it acts as open circuit. L at T equal to 0 plus. If no initial charge, current means no initial condition. No initial condition. Initial condition equal to 0. Initial condition equal to 0 means it is open circuit. Otherwise, it acts like a current. It has some, say, 1 ampere. I0 ampere. Then it acts like a current source. Direction may be opposing the applied or it may aiding the applied current, applied voltage. But direction this or this depends upon the current in that inductor. Current in that inductor. If it is pure resistor means transient as well as steady state all are same. There is no transient for resistor. Always steady state. Always steady state. But if you connect in series with capacitor, current through the resistor will have a transient current because of in series with the capacitor or in series with inductor. That's why there will be a transient. But if a resistor alone is there, there is no transient, only steady state. If you give 5 volt, suppose I am having a circuit like this. Voltage applied is 5 volt. Voltage applied is 5 volt. If you plot 5 ohm, 1 ampere always, 1 ampere, no transient, no steady state, always steady state. If it is resistor alone, that's why solving differential equation is important because one capacitor is there in the circuit. What is the voltage across the capacitor? VC equal to Vc equal to current through this is I of t. Current through this I of t means 1 by c integral of I of t dt. 0 to t or minus infinity to t. Vc equal to 1 by c integral of I of t dt. You forget about the limits. You should remember this. Limits you can put later. This is for voltage Vc. What is IC? IC equal to C dV by dt. Rate of change of voltage across the capacitor is current through that capacitor. This is the expression for current through the capacitor. C dV by dt. C dV by dt. From this you can get this. Differentiate on both sides. What you will get? dVc by dt equal to, if you differentiate this, it becomes I of t divided by c. If you bring that c here, you will get I of t. If you differentiate the first expression, you will get the second expression. If it is an inductor, the voltage across the inductor is VL of t. Voltage varies from 0 to maximum to 0. Therefore, VL of t equal to VC of t equal to L di by dt. L di by dt. What is current through it? IL of t equal to, we have to put small. IL of t, because transient varies with respect to time. That's why we are putting small. IL of t equal to 1 by L integral of V of t dt. VL of t dt. Voltage across the inductor. Dual expressions. These are called dual expressions. If you see for current, the expression for current for inductor is expression for voltage. The expression for voltage for capacitor is expression for expression for current of capacitor is expression for voltage of inductor. Only L and C are changed. The constants are different. These are all we should remember while writing the KVL.